Our next speaker, Dmitry Trukhanov, is living in Wrocław for 1.5 years. He's attending Toastmasters meeting to become a better speaker and also trying to improve everything around him. Please welcome on stage Dmitry Trukhanov with his speech, Blackbox Performance Analysis.
Thanks everyone to join me today because it's quite late already and last session is always quite hard in conferences. Blackbox performance analysis. I'm doing it a lot. I'm working in Luxoft as a performance engineer. That's what my position states. I'm doing a lot of stuff, and Blackbox performance analysis is one of the biggest things what I'm doing. What I understand under Blackbox performance analysis? Hey, no, no. Oh, strange, very strange. It's very simple on the first glance, and it's very, very simple. You're taking your program which you have developed, you're giving it to user do something with your program, you're getting metrics from your program and from operating system, of course, and you're looking at what is going on. And the next question, which for some reason no, maybe this way. Why on the earth do we need another type of tests? We have cut coverage. We have linters in the first place, which are telling us all the problems with our code. No? We having continuous integration, continuous delivery. We're having fuzzy testing, other testing, a lot of testing. And now coming me saying, oh guys, let's do another testing. And this test is quite time consuming. Why should we do such a thing as a black box performance analysis or black box analysis at all? No. I want to ask you very simple question. Who could try to interpret what is displayed here? Hand, please. Someone? Someone. What? It's a chart. It's a chart of metrics. But what could we say about this chart? What could it show us? Is it good program? Is it bad program? Who? Memory leak, yes? Memory leak, it's most obvious thing, of course. But no, it's not memory leak. It's another type of leak, and these types of leaks could be met very rare, but could be met really in experience. It's analysis of one program which quite standard for testing. I will not name it because of NDA, of course, but it's quite a standard for QAs, QA teams. And what it shows here is I/O operations leakage. What it shows here is that program, after each run of some operation, starts to consuming more and more input and output operations. What? How it is possible? It's not something that this program is trying to read something continuously. It's not something like this program is working hardly with file system. No, this program what only does is just an automation for just regular programs. So user clicks play, it plays some scenario and closes this automation execution. And it stays to consuming more and more input and output operations. Why? These guys have said me that it's not possible because why? We have tested our program quite good. Why? And I have said, sorry guys, we have real situation. I have not seen your code. I have not seen your approaches to code. I have not seen your approaches to testing. I have not seen your programmers at all. But I see your program. At the end of the day, it do very strange. Some very strange thing, like I/O leakage. It sounds crazy to my ear, actually. The other thing which I have seen, it was absolutely the same chart, like displayed here, but the only difference, it was CPU leakage. User was pressing in browser one button, and browser started to consume additional CPU. He pressed this button once again, just to repeat our operation, not to start some new operation. And CPU started to consume, program started to consume more and more CPU. CPU leakage. Have you ever heard about this? Me personally, no, because it sounds crazy once again. What else? It could be other crazy situations. Let's return to more common situations. Memory leaks. Memory leaks is all over the place. I know this conference is mostly for C++ developers, and C++ developers can see memory leaks quite often. But also, I'm working with programs written in C#, in Java, and I'm coming to guys showing absolutely the same chart and saying, "Oh, hello guys, your program is leaking," and they're starting. Wait. Our program is written in C#. It works on .NET. We have managed memory. Do you know what managed memory is? I'm saying, yes, of course I know. You think that memory leaks is not possible there? And they say, no, garbage collections do all the thing. And I'm saying, oh guys, sorry, but I have captured for 24 hours. 24 hours is not enough for your garbage collection. And they've started, you know, maybe your environment was not so good. Maybe you have set up garbage collection somehow not to work well. And because of that, we even have changed name of this. We do not call it memory leak anymore. We call it unreclaimed memory allocation, because some of the guys telling to us, it's not memory leak. I've just cached all the objects which I have received. And I've said, really? I'm just loading the same settings 10 times in a row, and you caching it every time? And they've said, yes. Okay. It could be. Maybe it's very different. Memory could be the same. What else? It could be handles. A lot of programmers, a lot of developers, I'm from Windows world, so I will be talking about handles. In Unix world, you could leak descriptors, of course. Handles. Programmers just creating some objects. They may be not cleaning it because it's really cached in this case, and they're creating more and more handles to the same object. And operating system is have very big tolerance to such situations. So you could allocate thousands of handles, 10,000 of handles, hundreds of thousands of handles. But anyway, in some point, operating system will start choking. It will start giving you some strange errors. It will produce some nasty errors and event logs in your logs in its Unix and so on. So everyone should remember not to allocate, and without really looking at your program as a black box. Not so many developers are able to see that they're linking the same objects many times in loops or something like that. What else could be leaking? Another very nasty situation is leakage of threads. Developers are allocating threads just to connect in asynchronous mode. Some servers trying to do some asynchronous job in background, and this is actually was the case with this program which I'm displaying here. So IOPS were leaking because they have allocated additional thread for each run, which was trying to read some configuration from the disk. So actually IOPS were increasing, but it was not reading actually not a single byte, because file which it was trying to read was not existing on file system. Crazy. What else could be? A lot of things. A lot of things. And actually, it could be very hard to determine these leakages during your development stages. It could be very hard to detect such leakages during testing stages, because what you are really testing during your testings, you're testing user acceptance. You're looking that everything works fine. You're looking that no logs are not displaying some strange operations. You're collecting your own metrics from your own application. So you're not trying to understand, not you, maybe some nasty developers, not trying to understand what is going in general, what impact your program having, what impact your program having on operating system itself. Because you maybe, or nasty developers once again, maybe not interested in operating system, because we all know that memory is cheap in our era. So why should we analyze it? But this could lead to some very nasty situations. And what I really propose to do with all these situations. Returning to the beginning of my presentation, I suggest to do Blackbox performance analysis. I suggest to everyone not to just look at your program which you have developed, not to look at some near systems which you are interacting with, for example, databases, for example, web servers, but look at operating systems in general as well. No, not working. So what do we need to do Blackbox performance analysis? Very simple. We need to collect metrics, operating system metrics for in the first place. In Windows world, you could do it very simple with performance monitor, which is built in any version of operating system. It could be server, it could be client, it could be anything. In Linux world, you need to do some additional steps. Metrics itself provided by operating system, but to collect it, you need to have some additional system like Zabbix, Nagios, maybe some fancy time series database. And you need to collect it and analyze. But it sounds very simple. But what could really go wrong with collecting? A lot of things could be very bad, go very bad with your collection of metrics. For example, baseline. I have seen some guys trying to, and you should see this actually in internet all around the world, database comparison, PostgreSQL versus MongoDB, something like that. People are comparing something which is incomparable. To do proper baseline, proper black box analysis, I suggest everyone to compare with something comparable. And under comparable, I understand baseline. What is baseline? Mostly it's one of two things. previous version of your application if you are 100% sure that your application is already running quite good. So it's not having any bad impact on operating system, on end user experience, on your servers and bills on Amazon maybe. And the second thing, you could compare your application with no application. For example, you have just developed a new Chrome extension. And it's very simple. To what could we compare your Chrome extension? Of course, to plain vanilla Chrome. Just capture some Chrome data, look at how it behaves in your environment, and compare it with your extension which you have developed. Test plan. I have seen also people comparing something not really comparable. They have, for example, in one browser have opened a Google start page, and on the other web tab they have opened some Pudelek.pl, don't know. And it's very different. They're seeing, oh, really? My application, which I have running inside of Chrome extension, is consuming more memory just because I have comparing Google to some very big website. Test plan is very important. You need to compare, you need to reproduce test steps one by one in each environment, in your baseline and in your program. You need to implement in this test plan the most common operations which users will be doing with your application. If your application providing, for example, collecting of some system metrics to send it further to you when it will be crashing or something like that, and you use this operation like twice a year, there is no point actually to understand what impact it has on your operating system, on end user, on your servers. Test the most common user applications. Time intervals also. It's very important to do all the tests with predefined test interval, time intervals. For example, you may be doing some HTTP queries to some server. And in one case, you are doing HTTP queries once an hour, and the other is once per 2 hours. Your web server could have different caching settings. In one case, you could see, or you could hit cache version. In other case, you could hit online version, and we'll see very, very different behavior on your application. So time intervals should be also predefined. Cooldown. Returning to these guys who are saying that in managed environment we do not have any memory leaks, we have only caching, we need to do cooldowns after each testing. For example, you have done some testing of your application, run user load, or maybe not user, it could be done on server as well, done some operations, and please wait for at least 30 minutes after it and see how operating system is behaving. Also, cooldown is very important for operating system itself. For example, when you're starting in one environment, your application, it could be checked by antiviruses, some DLP agents, a lot of stuff could be going on. And after closing your applications as well, sometimes you have allocated some memory and it was freed up. But sometimes when you have run your applications, consumed some memory, and closed even your applications, memory is not freed up. If you have allocated memory in system pools, if you have allocated memory in Windows, memory windows, I mean, of course. You need to have test plan with predefined time intervals and cooldowns. And in baseline and in your application testing environment, it could be similar. similar. The second, fifth thing, you need to use the similar tools in each environment. I have seen in my experience that some people were running, because to tell you the truth, who will run, for example, 24 hours capture and 24 hours running of applications manually? Of course, no one. Maybe some. We will use some automations. There are a lot of things all around the place. We could write something ourselves. We could implement something in auto IT, auto hotkey. We could implement something in Perl, even, do not know. A lot of apps watch one of the system, Tricentis task, as I remember, a very big system to automate this. And all these system, all these applications, all these tools having their own impact on operating system. Once we have almost failed product from our developers, inner developers, because of memory leaks in operating system. But further analysis showed us that it was our automation who really introduced these memory leaks into Outlook. So Outlook, automated through this way, was leaking more memory than automated other way. And we said, oh, yes. So your test plan with predefined time intervals and predefined 2 cooldowns should be executed by the same tools in your baseline and in your testing environment. And the very last thing, but not least, is environment itself. We know that Java is running on 3 billion of devices. We could test our application, for example, on on some smartphone or on some Linux or on some Windows, and would it be really comparable if we compare memory consumed on Windows, Android, and Linux? Of course, no. And this is quite radical comparison, but less radical is comparing different versions of libraries. For example, you're running your applications on the same operating system with the same predefined application set, but one library have different version from other environment. And could you really say that memory leak introduced by some application in operating system is really caused by your applications in this case, or by this library which have introduced some problems? To sum up, to do all this black box analysis, we need to follow quite simple things. We need to collect metrics, but we need to collect them in quite predefined and quite strict way. So we need to do each time baseline analysis. We need to prepare quite a good predefined test plan. We need to have predefined time intervals in both environment and baseline in our test environment. We need to introduce cooldowns to be sure that if we have some garbage collection, once again, if we have some operating system procedures which are cleaning something, if we're having some predefined tasks which are doing some job for us, we need to understand if they're affecting our applications or not. We need to use identical tools in each environment. And of course, we need to have identical environment in our baseline and in our test. And this is actually what I wanted to tell you today. And I wanted to encourage you to do black box analysis in your environment. And now it's question sessions.
If you have any questions, please join me here.
No one will be doing black box analysis, no? These guys who provided me with this chart were good programmers as well. Their program were doing very clever stuff. It was written quite good. They just forgot quite small line in their code which was not visible by statistical analysis, or not visible by linters, were not visible by cut coverage and unit tests and so on. So even if you are good programmers, it's very good to double check yourself, because it will give you better understanding how your program behave. For example, you will be seeing in which areas of operating system you're allocating memory, which drives you're writing to. Maybe in test environment which you are doing, you will have too big input-output delays, service time or transfer per second in Windows. It could be quite a lot of problems, and to make a step further to solve it, Blackbox performance analysis or Blackbox analysis is one of the tools could really help you.
Okay, I have a question. Do you have an idea of how would you integrate this into an automated continuous integration pipeline? Like running is one thing, and you could always probably generate some kind of report, but are there ways that you can automatically like pass or fade a specific version, or does it always require a manual review of the reports? Yeah, are there ways to automate this?
Great question, thank you. There are a lot of possibilities for automation, but to tell the truth, full automation of this process, in my opinion, is hardly possible. You could automate collection of metrics. You could automate your test plan. You could automate deployment of your environment, of your time intervals, of your cooldowns. But really interpret what is on the chart is a job for engineer. It's job for specialist who could really tell you what is going on and why it could be going on there. Because like on this chart, we could do maybe some how it's called, anomaly analysis for this. But to tell, but if you will have seen this in previous version, anomaly analysis will not do anything in your case as well. So to include in CI/CD, it's always possible. But interpret results, it's to a human for now. Maybe machine learning will be replacing us soon, but code will be automated as well in this case. So none of us will be needed in this case.
Yes, hello. Thank you for your great talk. And I have a question. So I work in a field where it is not a big stretch of imagination that we are the owners of the one and only product of its kind. And it might be a very basic question, but in this case, what would you select as the baseline? So we have one of a kind application and we want to find a baseline for our black box testing.
Thank you for your question. As I have said before, if you are 100% sure that your application is running quite good, at least one version, you could select your production version as a baseline. You could test it on your own and without comparison, for example. You could compare your production version to not having your application on environment, and then use this application, production application, as a baseline, and then compare your new developed versions to this already deployed production version. This is what we are doing, at least. Thank you. More question?
I don't see anyone anymore, so thank you.
Here we have one.
Okay, please come. Wait a second.
Wait a second, please. Microphone. It will not be heard.
Because we can use, for example, the profilers to see the memory leaks and analyze the performance of our language, and usually they are built in IDs. So what's the difference in the tools you are using, and what is the advantage it brings?
Okay, thank you. Thank you for your question. With profilers are quite narrow area tools. They're providing limited set of metrics which they could collect actually. Memory leaks is one of the most obvious things. But as I have showed you in my presentation, we could have many different problems related to operating system itself. Leaking IOPS is just one. Leaking CPU profiler, which will show you leaking CPU. Okay, you could collect CPU load. Most of profilers could provide you with this. But for example, I/O. For example, threads could be handled. It's the matter of general usage and narrow usage. If you are 100% sure that your application will not introduce any unknown behavior to operating system, you could use profiler, because profiler will be analyzing your applications in quite a little bit smaller area. Black box performance analysis from operating system perspective will show you a more general picture. So this is why I recommend not to limit your testing only to profilers. Because, and also profiler mostly useful during lifetime of your application. And for example, you will not see what happened to operating system after your application exited, after your application maybe crashed, after your application have closed main process and started some childs. So operating system knows all about this, and in this case, it will be showing a little bit bigger picture than profilers. That's why.
Do we have any further questions? Okay, we have one.
Hello, thanks for your speech. I've got another question related to baseline, I think. I'm wondering, and I can see some kind of risk with choosing the baseline. I understand that if we know that our program is on the level that we know that there is everything okay, we have a release version, and we can use this program as a baseline, it's okay. But what if we are producing the program for many operating systems, and we don't know which version of our program could be the baseline version? So we need to check our program, I think, all operating system that we are compiling our program for, yeah? So how you are choosing this operating system and how you are choosing this baseline? Because the question is, because I can see the risk if you choose the wrong baseline, I mean the wrong operating system or wrong version, and on some level of testing you will see that there is the leak of something, and you cannot compare this to some other results because you are comparing this to the baseline, and on some level you don't know if there is the problem with the application or there is a problem on the operating system. So if the real question is if you have many baselines to compare baseline between, or some more tests to have this comparison.
Great question, thank you. We have this situation in our organization. We're testing mostly for end user applications. We're having Windows 7, which is quite old, and we're migrating to Windows 2016 Terminal Edition, and we are migrating to Windows 10, and we having and this operating system behaving differently in different situation. What we are doing inside of one operating system, because even for one operating system we have different environments. We have VDI, we have workstations, we have server side. we're testing for each operating system. So, for example, we're having Windows 7 and Windows 7 deployed in different environments: workstations, VDI, some maybe laptops. We're choosing the most sensitive environment for this operating system. In our case, it's VDI because it's aggregation, it's contention, and when your program is leaking in by some means in your own workstations, it's one thing. But when it's leaking on VDI, when have consolidated many leaking on one physical servers, you could have problems quite quickly, quicker. So my advice is to do baseline collection for every operating systems, but for one operating systems, you need to choose most sensitive. It's more limited by resources, most likely, or maybe you have something like critical zone users and just take their configuration. That's our approach, which we are using actually. So test each operating system, but choose most sensitive configuration inside of all the variety inside one operating system. Thank you. More question?
Two questions. The first one: how often should we perform this black box analysis? And the second is more about high performance computing.
Mm-hmm.
Do you check, or should we check, the performance of the application for the same system but for different hardware configuration? And should we focus also on some low details like CPU, cache misses, or should we take care about these features on lower level of tests?
Could you please explain what you understand under high performance calculations, because it could be different.
So actually, your talk was mostly focused on memory leakage, I/O leakage, and interaction between system and the user application.
Mm-hmm.
But for example, let me assume that I'm working for some artificial intelligence AI program,
Mm-hmm.
and I have a lot of loop and a lot of that data.
Mm-hmm.
And in that case, I don't have a lot of I/O operation,
Mm-hmm.
but I have a lot of calculations,
Mm-hmm.
and the cache, CPU cache, and efficiency of the cache usage is for this program more important than a simple I/O operation. And that's why I'm wondering.
Is it running on one node or many nodes?
Let me assume for one node.
For one node, okay.
So should we take care about these issues on the black box,
Mm-hmm.
or should we perform, for example, should we profile our application and focus only on data processing function, like unit test or something like that?
Okay, thank you. Great question. First, how often should we do? In our world, when we are having 100 deliveries per day, 100 releases per day, it's quite hard to do quite often, because this is quite time consuming. We are dealing with quite normal waterfall process when delivery is done in monthly cycles. So we're releasing one versions once a month. In this case, for us, it's much simpler, and we could test each version which we are delivering. In situations which you are delivering several times a day, several times a week, it could be quite hard. In this case, you could choose some compromise. So test only minor versions, test only some features when some features are released, or every 2 weeks, for example. We have another project which is delivering quite often, and we are doing longer captures, not 24 hours captures, but 72 hours captures, just on regular basis. We are not receiving new version of applications, we're just collecting all the metrics and seeing what is going on. Is it okay, is it not okay? We're not producing reports, we're not producing releases, we're just looking how it's going on. In this case, it could help in this case. For high performance, you're talking more about application-specific performance. What I'm talking here is more general performance. Performance, what is will be visible when it's too late, for example. For your approach, you need to do some analysis inside your applications, because you know how your application is working and what you really need. You could do a lot of stuff during black box performance analysis as well, because cache hit or miss, memory paging, and something like that, you could collect this. But in this case, profilers will be, I believe, more useful for you, because you want to understand performance of some small part of your code, not all the application itself. All application itself could be also analyzed as black box performance, because you could find something which you have never anticipated in your program. Maybe it's creating some another problems. And your specific performance should be done during your development stages, refactoring stages, profiling stages. So I propose you to split these operations. Any more questions?
I've got one more question. I promise that will be the last question from my side. This is the question about the results of your analysis that you are providing to managers, to software developers, and all people. The question is if you have any targets of the results. I mean, how you are preparing your test scenarios, if you are using some requirements for the software, and how do you know what numbers are the good numbers? I'm not thinking about baseline, I'm thinking about the results. How do you know that, and who is preparing the test scenarios, if it's only you, or if you are preparing this targets and these scenarios together with someone?
Thank you. Where do we get test scenarios? We are getting it, of course, from developers, from business analytics, from product owners. We asking them to provide us with most common user operations. Once again, if your application have some feature which is used like once a month, twice a month, there is no point to analyze its performance, because even if it's just sending results to you as a developer, or some aggregated statistics which is used once a month, there is no point to engage it in normal black box performance analysis. We are analyzing only most common used operations, what is used on daily basis, on hourly basis, not even on weekly basis. So if it's used quite often, we are including it. If your application is engaging some other applications, interacting with some other applications in operating systems, we also testing these applications, and most likely we already know how to test it. For example, once again, if you are developing a session for Chrome browser, you already know how Chrome browser works. You need to open tab, you need to open some page and look how it's loading. You need to open another tab, load another page, reset to about blank, for example, and repeat several times. Who receiving our reports? In my organization, before our team was created, it was a little bit chaotic. Everyone could develop and deliver everything to servers, desktops, mostly desktops. there were a lot of different teams developing absolutely different programs, and they all want our users to have it for sure, because one user in an organization uses this and all others should have it. And at some point, users started to cry, going to their managers, asking managers to go to higher managers, higher managers, higher managers, and finally CIO created our team to prevent people delivering good software from good developers, but with some unpredictable features. So now we could veto any release delivery to end user workstations because of performance problems. So our reports is going directly to developers. If it's okay or not okay, we have currently only 2 states. You are pass, you not pass. Previously it was like, oh, we are allowing you to pass, but please fix this. Now anymore, no. Just pass, not pass. And we're aggregating all the information and sending it to higher management just to a little bit brag ourselves and showing that, oh, guys, we have saved our organization from these sufferings and to show that we're earning our bread not for free. Thank you.
I think we can conclude this session, as I don't see any other volunteers or questions. Okay, please give a big round of applause for Dmitry.